Electric baseboard heaters. Nothing but the warm, hard facts. Molded pulp containers. This ain't pulp fiction. Prepared chicken. Passing the buck, buck, buck. And video games. Warning, this report contains graphic scenes. Electric baseboard heaters are inexpensive, easy to install, and practically maintenance-free. Unlike radiators, they're inconspicuous, and they take up very little space. And best of all, you can control the temperature room by room. A baseboard heater is simply wires and a heating element in a steel casing. They make the element using a strip of paper-thin aluminum 19 centimeters wide. It's lubricated with soap, then goes through a forming machine. A die punches the strip into little squares called fins. They measure 16 by 20 millimeters each and have a circle in the middle. The machine pierces the circles and cuts the fins apart. This machine churns out 600 fins per minute. It stacks them on steel tubes, the lengths of which vary according to the length of the heater. As each tube fills to capacity, a worker takes it away to be wired up. Elsewhere in the factory, meanwhile, they make the heater's casing, using what's known as cold-rolled steel, a flexible type of steel that can be worked without using heat. After a squirt of oil for lubrication, the first die cuts holes for attaching the baseboard to the wall. Then the second die cuts holes for attaching the heating element to the casing. Now the steel travels through what's called the roll former, a machine whose series of rollers successively bend the flat strip of metal, one fold at a time, into the shape of the casing. From start to finish, 20 rollers make 20 bends. The process takes exactly 146 seconds per casing. After the last fold, a computer-controlled die cuts the casing to the required length. The higher the heater's wattage, the longer the casing has to be. Models range from 300 watts, about half a meter long, to 2,500 watts, almost 2.5 meters long. Next, they put a steel junction box on each end of the casing. These hold the wires that the electrician connects to the house wiring. Workers spot weld both junction boxes simultaneously. After a thorough washing, computer-controlled sprayers coat the casings in paint powder. Then it's into an oven for about 20 minutes at 185 degrees Celsius. This transforms the powder to liquid, drying it instantly. After running a red wire for the electrical current the length of the casing, they rig up what's called a linear high-limit temperature control, a safety device that prevents the unit from overheating and catching fire. Gas inside the temperature control expands under intense heat, triggering the device to cut the current. Now they install supports to hold the heating element in place. They're made of satin coat steel, a rust-resistant metal. As the element heats up, it naturally expands. To prevent it from scratching against the metal casing and making annoying noises, they install a heat-resistant plastic bushing. Now they connect the red wire that'll carry the electrical current to the heating element's black wire, capping it with a wire connector. They clip it to the cover of the junction box, easy access for the electrician installing the baseboard. Then they close the junction box cover. At the other end, they connect the red wire and the black wire to the temperature control wire. This runs the electrical current through the safety device at all times. After a voltage test, they close her up and snap on a panel to cover the element. Being toasty warm is now just an installation away. Molded pulp isn't exactly a household word, but it is a household item. Chances are you've got an egg carton in your fridge that's made of it. This thick cardboard-like material can be shaped into a variety of containers, such as those drink carriers they give you at the fast food restaurants. Farms ship out their eggs in trays called filler flats. These flats begin as recycled paper. Old phone books, newspapers, magazines, cardboard, pretty well any product made of paper fibers. The factory even recycles its own flats that have been rejected by quality control. The raw materials go into what's called the pulper, a giant blender that mashes everything up and blends it with hot water that's 43 to 65 degrees Celsius. The hot water swells the fibers, causing them to break apart. After 20 minutes, they become pulp, a watery mixture roughly the consistency of hot oatmeal. The pulp exits out the bottom of the pulper through a filter that screens out plastics and other contaminants. Shaping the flats is a fully automated process. Formation molds descend into a vat filled with pulp. A vacuum sucks the mushy mixture onto them. Water jets rinse off the excess. Rotating above are transfer molds. They grab the flats off the formation molds and move them onto a conveyor. Before the transfer molds grab the flats, though, a brush applies a water-based lubricant. This ensures the flats won't stick to the molds. It's just like greasing a baking pan. The molds themselves are made of bronze, plastic, or aluminum, depending on how long the factory intends to use them. They're covered with a stainless steel mesh. This mesh ensures an even vacuum through the mold so that the pulp spreads over it evenly. The soggy flats now go into an oven for 12 minutes to dry out. The 205 degrees Celsius heat evaporates the water. This bonds the fibers together, forming a rigid material. After they exit the oven, a device appropriately called an upender flips them up so that they stack into each other. A built-in counting mechanism triggers the machine to section off the required number of flats per package, then compress them, and seal them in plastic film to keep the dust out. The factory uses the identical molding process to make 4-cup drink carriers. These too go into an oven to dry out the pulp, but only for 6 minutes, half the time the filler flats need, because this product is smaller and lighter. Automated compactors stack the finished drink carriers. Then workers compress them for packing and shipping. The factory also makes disposable urinal bottles for hospitals. They add chemicals to the pulp to make the bottles liquid tight. These molds are three-dimensional and lined with mesh on the inside. When they submerge into the pulp vat, a vacuum sucks in the pulp. When they resurface, water jets rinse the excess pulp off the bottlenecks, and the vacuum sucks out the water. A spiked conveyor belt transports the bottles to the drying oven. They dry at a lower temperature than the flats and drink carriers do, 176 degrees Celsius, and for a longer time, a half hour. This ensures the chemicals making the bottles liquid tight cure thoroughly. While urinal bottles can't be recycled for sanitary reasons, drink holders and filler flats are recyclable, making them extremely environmentally friendly.